Okay, so today we are going to explore patterns and work with patterns and how we can turn those into algebraic expressions and rules. And so here I have a pattern set up. So we have a square with 4 sides, and then we have this rectangle with 7, and this longer rectangle with 10. There's 10 toothpicks. And so we need to figure out what's the how many sides we're adding to get to the next step. And so if we look at this, we can create this table. And so we have one square which has 4 sides, and then 2 squares, which is 7 little toothpicks, and then 3 squares, which is 10 toothpicks. And so we're trying to figure out the relationship between the amount of squares and the amount of sticks in in the square. And so there's a difference of, we have 4 to 7 and 7 to 10, so there's a difference of 3 between those. And so we're adding 3 between all of those. And so there's a pattern that we picked up on. So now we need to make a rule. And so if we can try, if you pay attention, if you investigate, that you discover that the rule is 3x plus 1. So if you do, see, like we have so say x is 1 first, we have, no, yeah. And so we have 3 times that plus 1 equals 4. And so that works out for the first square. And so now x would be 2. So we have our 3 plus 1. So we have 3 times 2 equals 6, plus 1 equals 7. And then we have our 3, and so x is 3 this time. 3 plus 3 equals 9, plus 1 equals 10. And so the 3 is the constant because it's the slope. It's what's changing in between each of the amount of sticks that is changing. And so if we keep on going down the table, we'll have the 3, and then we'll have times 4 plus 1. So 3 times 4 is 12, plus 1 is 13. So if we go back to our table, we can fill that in. We can just work our way down. So we'll have 5 and 6 and 7. Then we'll have 3 plus 1 plus 1 plus 1. So we have 3 times 5, which is 15, plus 1 equals 16. So we can go to a table and fill that out. And then 3 times 6, which is 18, plus 1 gives us 19. And 7 times 3 is 21, plus 1 is 22. But since we have this rule of 3x plus 1, we can plug in any number that we want to for x, and we'll get the number of sticks. So say we wanted to, if we had 20 squares, we could figure out how many sticks that would be. And so we have 3 times 20, which is 60, plus 1, which equals 61. And so say we wanted to figure out how many sticks we would have if we had 50. If we had 50 squares, we could just apply the same rule. We have 3 times 50, which is 150 plus 1. So it would be 151. So just to review, we can figure out an algebraic rule just from a pattern. So number of squares in relation to the number of sticks in each. And so once we figure out what's changing, we can go and create an algebraic rule and apply it to our pattern and use it to fill out a table and figure out any number of variables that we want to. Okay, so today we are going to be working on problem structures with word problems. And so we're going to have 2 word problems, and we'll do one problem at a time, and we'll go through and read the problem, present the information within the problem, and represent that on a specific type of diagram designated for that problem. And so let's get started. So problem 1. William and Sally put 160 marbles into a jar. William put in 83 of the marbles. How many marbles did Sally put in? And so the important stuff to take away from this is that we have William, which I'll just put W, and we have Sally, which I will just put, that's a backwards S because I'm writing sideways. There we go. That looks better. So we have William plus Sally, and they had 160 marbles put together. And we know that William only put in 83 of those marbles. So if we know that when William had 83 and Sally had an unknown amount, and together that's 160. So we know the total, and we know William's part of it, but we're looking for Sally's because we don't know how many she put in. And so what this problem, since we know the total, and we have William's part, and Sally's is another part that we don't know, we can use, it's called a part-part-whole problem, and so we can use a part-part-whole diagram. And so we know that the whole, which is William and Sally's marbles put together, is 160. And we know that William's, which is one part, is 83. And we're looking for Sally's part. And so to do this, we can take our total of 160, and to get Sally's part, we'll need to subtract 83. And so we can't take 3 from 0, so we have to go over to the 6 and borrow, so that'll make our 0 10. So we have 10 minus 3 equals 7. And then we can't take 8 from 5, so again we have to borrow, so that 1 becomes a 0. And the 5 becomes a 15. So we have 15 minus 8, which is 7. And so we have 77. So now we know that this X, Sally's part, is 77. So we can go back to our diagram and we can fill that in. So we know Sally's other part is 77. So we have William's 83, Sally's 77, gives us a total of 160 marbles altogether. And another way that we can show this problem is by using strips. And so you'll have one strip, which is the longest, and that represents our total of 160. And then we have this longer part, which can be William's, is 83. And we were looking for X, which was Sally's part. And once we subtracted 160 and 83, we got 77. And so we have our total, and then a part, and the other part. So how many marbles did Sally put in? Sally put in 77 marbles. So that's one problem. So now we will move on to problem number 2, which is Cindy had a collection of 35 baseball cards. Cody gave her some more. Now Cindy has 120 baseball cards. How many cards did Cody give her? So Cindy had 35 and Cody gave her some more. I'll put Cody as CO and we'll put an X there because we don't know how many he has. And now the total, so we have C plus CO equals 120. And so we're looking for how many cards Cody gave Cindy. And so to do this, we can use the compare model, which is kind of like our strips, and that we have our large set, which is the 120, because that's all of it, and we have our small set of 35, and the difference, which is our X. And so to do that, we'll need to, kind of like the last problem, we'll need to take our total of 120 and subtract 35. So can't take 5 from 0. You go borrow. 10 minus 5 is 5. Can't take 3 from 1, so you go borrow. And 11 minus 3 is 8. So we have 85. So that means our X, which is how many cards Cody gave Cindy, equals 85. And so, just to review the model, we have the total, the large set of 120, the small set of 35, and our difference of 85, which was the smaller set, or technically it was the bigger set. And so we have these strips, which is basically the same as the compare model. And so we have our large set of 120. We have a smaller set of 35, and we had X, which was the amount of cards Cody gave Cindy, but we subtracted and figured out that Cody gave Cindy 85 cards. And so we have our 2 smaller sets equal the 1 larger total set. And so that is how we can take word problems and apply specific diagrams to them, and they can help us solve word problems in a more visual and helpful way.